Good evening, everyone. So I'm Suresh, and I'm going to talk about the anomaly alpha for prediction in Apache CloudStack. Uh, Myself and he's a co-speaker. Both were working in this POC. Um, so we are experimenting on some of the machine learning models. So this is the agenda. So I will just go through the introduction and the proposed system features and various data sources which can be used for applying machine learning algorithms, and a brief on the architecture of the prediction system, how it looks like, and the solution approach, and the various resources that has to be involved as part of the data set, and the algorithms, and the summary. So in the CloudStack, we see in the data center environment, there are a lot of chances for a system or host failures or storage failures. So it means we'll get to know that failures either with the alerting system or the monitoring system. So even the efficiency of the IT ops is not the superior customer experience. So always the support team gets the problems reported from the customers. So and due to the huge data and the velocity of operational data in the CloudStack, so you can see the incidents detected by customers before support is ever. So I think there are some statistics which says 76% of incidents were detected by customers before customer is aware, and 66% is says existing monitoring solutions identify less than half of all performance issues or outages, and 56% is a growing complexity is leading to more outages. So because of the challenges in CloudStack or data center environment, instead of depending on alert or monitoring tools, it is better to detect and take necessary actions before actual problems occur. So for that, there should be a smarter solution which complement the existing monitoring systems, and which will maximize the operational efficiency. So these are the proposed system features. So I will go through one by one. So data extraction. So we have various data sources. The log files. So CloudStack generates huge logs. We have management server logs, system VM logs, and we have logs in virtual router, console proxy VM, and secondary storage VM. So, and we have database which captures various events and the states of various resources like host, storage, or network at different points of time. And we have some alerts like storage is out of space, or host is not connected. Such alerts being captured, and the events. And the threshold limits which we set for a secondary storage using a global parameters, and the CPU usage and the memory usage in the hosts. So these are the various data sources which can be used in the ML, which can be used in the ML algorithms. And failure prediction. So after extracting the data a model will be created a machine learning model will be created which can be used to predict the failures. And in turn, we will get a notification. Suppose a number of logins failed at a given point of time. Say in 1 hour, 5 logins have been failed. So we will get immediate threat notification and recommendations. For example, recurring snapshots has been set. And the system is taking daily recurring snapshots at some point of time, and admin doesn't know at what time the threshold limit reaches. So the system knows day by day recurring snapshots has been taken, and some point of time your storage will get filled. So the system will immediately suggest that at this point of time the system might fail, so either clean up or add additional storage. And integration with external issue tracker like Jira. So if there is gets any issue, based on the severity of the issue, it immediately creates a ticket in Jira so that any engineer can start working on that. And integration with monitoring systems. So the system will take input from the monitoring systems, all the alerts or any event or notifications from the monitoring system for different prediction analysis. So this is the architecture of the proposed system. So we have various data sources, and all are at the real time are passed through data extraction layer, and we have a scanner and filter. So we have different scanners for each input type, for log, for database, for monitoring system, for events, and we apply certain filters on that. Maybe the threshold limits or the resource states, or might be it is failure type, and the unstructured data from the logs will be converted into structured data, and that is passed for the prediction. So the same data is been captured in the database, so that can be used for retraining the model. So the initial model which is being created doesn't give a better accuracy. So the data from the system is recorded, and initially at frequent intervals the model is trained so that we can achieve the better accuracy. So we have in the model it detects various patterns. It can be failure usage patterns or state change patterns of various resources. It can be storage, network, or a host. And based on the output from the model, so we will basically get a classification what kind of failure it is and what is the severity, and based on that either the system will decide it should report or notify to the admin that this is the problem, or it has to create a ticket in the issue tracker, or it will recommend base. If it is a storage, it will just for example in the recurring snapshot it will just recommend either clean up your storage, or maybe you can expand your storage, or if there are any autonomous operations, even it can also maybe self-heal itself based on the operations. So this is a solution approach. So create a data model with the historical data of the CloudStack using various data sources, and scan and filter the data. Basically, you annotate the data and extract the entities out of that, and derive patterns from that, and then send that to the model and process output from the model. So basically, we are working with the AI and ML team in our organization, and we have passed the data to them, and they have shared some accuracy reports, so which I will show in the next slide. So once the process the output from the model, based on the output, either we can notify the admins or recommend the admins, or it can self-heal. Okay, so these are the various resources and the attributes which can be used for analysis and prediction. Storage device, so we can consider the capacity and the state of the storage, it's active, enabled or disabled. Network devices, we can any packet drops are there or any link status. Sometimes we see connection timeout in our logs. So maybe instead of debugging, instead of root causing, we can automatically apply or figure out some patterns, and based on that, maybe we can notify the admin to or recommend the admin to take necessary actions. And compute nodes. So the average CPU or the based on the average CPU or the memory utilization, we can recommend that maybe this host doesn't have enough memory or CPU. Maybe either you can add a new host or delete unused VMs or something like that. And database. So even sometimes we see there are a lot of IOs happening in the database. So maybe based on the usage, if there is a different database server configured, we can alert accordingly to the admin. And a management server. So when sometimes because of the huge logs within the management server, we see heap out of space in the system logs. So before going to that state, we can monitor the storage and memory of the management server, and immediately we can alert the admins. And we can also consider system VMs, virtual routers, secondary storage, and the console proxy VM, and the load on them, so that there is zero downtime. And these are the algorithms. So basically we tried different models and algorithms for some use cases. So these are the below methods we have tried out, and from that we can pick what gives the best performance and the accuracy. So the results which we get from our AI or ML team is this. We shared couple of log files. So with that, they have applied these methods, and so we have seen linear support vector classification gives the best accuracy. Prediction using a log file. So how we predict a log file? So using a management server, we tag various debug files, like it can be error warning or info, and the entities can be management server. The log can state it's belong to management server or virtual router, primary storage, secondary storage, or database, host, or network. And the particular log can be a normal log or an error log. And we can say if this is a error log, what kind of error it is, what kind of failure it is. So we can define the failure type. So if we have a set of data, maybe we can train set of data. Maybe we can partition that, and we can train with some set of data, and using the same model, we can test with the rest of the data, so that we can see what is the accuracy with that model.
Just 1 second.
Yeah.
So we got too many inputs of different types and too many algorithms to apply. So we have just chosen something small to start with and see what we can get out of error logs or management server log to start with. So what we're trying to do is classify lines. We have clean up lines, time, stamp, and all that stuff. And then written some scripts to auto-categorize whether the storage related, management server related, etc. And then manually go on and say, oh, this looks like an error condition and had occurred, etc. And then we're trying to take all that and apply a few algorithms to see if we can kind of predict whether which are the errors, which are not there. And once we have that done, then we can apply the live stream of log to the model and see if we can predict the same thing. So that's the small part that we're kind of focusing on right now. But the whole problem is very big. How to take topology information, how to take monitoring data, etc. So we kind of start small projects like these and try to see where we're getting more success. And wherever we kind of see value, we kind of share the techniques and say, okay, this is what we tried, this is what we got, good, bad, agree, this is where we are. Maybe, we can kind of work together to see. The other problem challenge we see is kind of getting all this data in the way we want. Like all historical data should be available. Management server information should be there, etc. So we're just kind of trying to handle too many things together. We're just kind of piece by pieces.
Yeah, it's a very, very interesting subject. This,
Yes.
It really needs to be addressed. The word topology was in the middle of what you said, and
Yes.
I think what's close to my heart is that whatever happens here, that topology has to be both in terms of the physical topology, the infrastructure, right, the data center, the zones, but also the logical topology, from a user, application, and account perspective, so that you can really understand what the impact analysis, do an impact analysis of what this data is showing.
Yeah. So I think this is just kind of I think there was another AI ML talk which explored different angles, like where all it can be applied.
Use cases.
So I think maybe we should start seeing how we can do this systematically.
Yeah, you have that architecture diagram at the beginning of the presentation. There's something in there that I wanted to question. That's like the way you have the data flow. You have the persistent store, or let's say the big data repository, off to one side.
Yes.
But you showed the flow through data extraction to the prediction model. That structured data.
Yes.
So
this is not really a concrete physical architecture.
No,
you don't really see that.
So
this is being constructed that way.
The idea of this is to suggest that some of the models will work on real-time data.
I was going to say
some of the models will use the historical data.
Historical data to train.
Side, right?
But is that complexity necessary? I mean, if you're near real time.
Yes.
Oh yeah, why is that?
Yeah, because you want to store your real time data so that you can keep fitting your model.
To retrain so that
your accuracy.
Accuracy will be increased.
So actually, and it is you will make decision on sliding window of data. So you will not typically train the same model from beginning of the time, right? Because you want to look at last 8 days and see if snapshot pattern is drastically changed, or you will have to pick a window on which you want to work on. So you will have short-term models and long-term models.
I was thinking about that. I mean, you're seeing the emphasis here appears to be on like break fix or predicting failure in the system, but that can happen in the short term, like an incident.
Correct.
It can also happen in the long term, like capacity planning, like over weeks and months, trends like that.
So that's why if you see in the model type, in the model watch we got failure patterns, you got usage pattern, and usage pattern is your usage analysis, how is it doing, and whether it will run out now or quicker than what we had thought, because people have suddenly 10 tenants have started snapshotting all their VMs.
So at that point, it's
Yeah.
a classification problem, that's a prediction problem.
Correct. Correct. Different kind of model.
Yeah.
Yes.
So the only break in this presentation is we have started with the bigger picture and many of this stuff, but we started just working on the smaller log problem and see if we can classify. And hopefully, our aim is to see if from the log patterns, like repeated errors in certain way, in certain complexity and frequency, if the model itself can say, hey, you're likely to get these kind of problems, or your system is running with potentially these problems, likely to occur though they haven't occurred. That's the goal.
Now, do you see this as intrinsically something to do with CloudStack, or it's just like in cloud infrastructure management in general? Is this not a product in its own right?
So this is the way to think about is we are not suggesting this to be kind of closely associated with CloudStack. Any work that you do in AI ML has to be for a particular domain, for a particular thing. So algorithms will be the same or similar in any infrastructure. Any cloud. Yes, you can have a. No, not. I did not mean that. What I meant was there should be the topology similarity, right? We have zone, etc., domain account, etc. So long as those models are same, then we can probably do similar thing. But if you take logs, right? Logs for each system is different. You cannot do even OpenStack and CloudStack. You cannot use one or the other. Correct. So that's why some of these pieces are specific to CloudStack, and some of these would be generic, right? So if you find a success in particular model for processing OpenStack and solving those kind of problems, if you give the same model similar features from CloudStack, you should see success, right? So it's a good starting point.
But the training data set is different for both OpenStack and the CloudStack.
And another important thing is
the fundamental algorithm or approach
can
be the same,
approach is same.
Yeah,
Yes.
and this will also another thing to keep in mind is this will also differ from deployment to deployment.
Yeah, exactly.
Right. So you may see a different fit for small deployment versus large versus very complex deployment. You see totally different things working for you.
I don't know. Do you have an opinion? I can't remember ambivalent. Like you'd imagine for a richly functional cloud management system, you need this kind of capability, right? So is this something that should be intrinsic to CloudStack?
I don't think.
Or is it something just aligned with?
Were you done with your presentation?
Sorry?
I thought we had questions.
Yeah, I think it's.
Yeah, I'm almost done.
Oh, sorry, I thought I already saw.
We are just explaining.
No, I think this is
That's
is
all.
what we are.
With me, honestly.
So once we are done with our proof of concept, maybe we will share all the findings to community. So
you have a concrete
yes.
proof of
Yeah,
concept
that's what we are trying to
Yes.
implementation. Well, we're very curious. We'd like to see it.
Okay. I think that's
your
all.
first training model, did you use real data, or did you somehow augment it? Because that's where anomaly detection models have a problem, that anomalies by definition happen so rarely that sometimes it's hard to train a model for it. So
we have taken the real logs, trimmed them, and cooked some of them, and that's what we're kind of trying to see. If you can simulate some of the most common ones and see if we get success there, then we'll pursue that path more. If you don't see a way to it. What I'm actually, so right now it is, if you see kind of this pattern, it is this classification, but I don't think that's very interesting. It can be a simple regex, and smart regular expression can probably do it. What I'm looking for is certain behavior or certain patterns before the actual error occurs, if that can be tagged somehow. So that's where we are kind of discussing and evolving and to see if we
Okay.
can do better.
We'll try to share the results as soon as possible.
Yeah, get the initial ones.
Oh, you can see there's different aspects of everything. Like, if I think about I get like agent connections from that, like just coming in and out. That pattern shows up in logs, right? And you can train the model to understand that some corner of the infrastructure is obviously got some sort of another one would be like 513 resource errors and such like. And capacity related.
Sorry?
What does the data look like in terms of parameters? What parameters are you extracting from the logs? And how are you labeling it?
So we have some scripts that will label the lines. So first is the error, debug, etc. The data classification is straightforward. And then depending on the line, we say, oh, this came from storage subsystem, or this looks like this will affect storage or capacity or something like those lines. And then we're just feeding it right now to these models to see. So we are also experimenting there what and how much data to add.
In terms of dimensions, like what is the originality that we are thinking with the classified?
You know how many
Sorry?
fields do we have? How many
Classification.
This is, remember we talked about the what type it is, what class it is, entity,
Okay.
and
Actually, I don't have that details with me right now.
well,
I'll
we'll put
share
up
with
a
you.
we'll
Yeah.
put up a proper
Yes.
But actually,
documents
something
and
that could be that's essential to the project, and it would be rationalizing, structuring log data. To make
Yeah,
it
actually-
more normalized, more usable, not just by systems like this. I mean, lots of people just dump
Actually,
all
that's
the
a good
PowerShell
idea.
logs into a log aggregator like Splunk or something.
Yeah.
Makes Splunk queries a lot easier. We've got
That's a good idea because we are kind of doing the same thing,
You just
raw
do it
log and
after
after
the
the fact.
do it as
Most-
part of the project.
That's a
and
good
then,
idea.
Everybody benefits from cleaned up, more consistent logging.
That's a good idea. That's a good point. Because this is, I think, the more complex and more larger environment, I think we'll need some help like this to do better than what we can do.
Oh, I would borrow.
Okay, thank you guys.
Thank you.